This is going to be a demo on building lesson 4, exercise number 1 in the Richard Cousins book. Help you get your profiles built. I like to let you experiment with it, try it on your own, and then I will show you a technique that might go a little bit easier and faster than the way you did it, and also to cap some of the most common problems I see. So I am going to build this profile and show you how I constrain this. I know it's perfectly constrained because it's fully constrained, and if I analyze this, I see I have the closed profile. There's 2 closed profiles, and also it is fully constrained. It tells you it's constrained in the little box, right? So I thought what I'd do is just do it from scratch and just show you how I go about building the part. I thought I had a clock here. Anyways, we'll see how long this takes us. What we would do, and there's several ways to create this profile, but I'm just going to create a box. I think it was about that big. 1, 2, 3, 4 high, 1, 2, 3, 5 wide. It doesn't matter. You can always dimension it later, change the values. So I create this much of the shape, right? And then I don't worry about the exact values. I just create the shape, blow out the profile, and I'm going to use auto constrain, and I'm going to auto constrain this, and then I'm going to go back to auto constrain and constrain the whole thing. Stack it, highlight the top, put it on the chamfers. It's a 1-inch chamfer at a 45-degree angle. I select this line and this line here and set those as your anchors. And that part's fully defined. Okay? Some of the mistakes I see that are most common when doing this part is this here is the hypotenuse, and that's not how they do those angles. Okay? They measure over a 1/2 inch and then cut it at 45, or measure over 1 inch and chop it at 45. You're not going to measure and try and get a hypotenuse of 1 inch. But for some reason, the Dassault systems defaults it that way. All right, but in the shop, that's not how they make it. Okay. So I'm going to undo and back out of that and show you why that was a problem. I'm going to go to chamfers with them already highlighted. I'm currently in the hypotenuse and angle. What you really want to do is use a length and an angle. So if you've ever used a chop saw, normally what you do is you mark off however much material you want to cut off, a 1/2 inch, 1/4 inch, whatever you're doing. Put a little mark there, you drop your blade on the chop saw on that mark. Then you lift your chop saw, you start your saw, and then you come down, you cut your material. So, same principle when you're designing. I think if you think about how you would make a part, that's how you want to design the part too. So I'm going to activate the length and angle, and the angle will be length will be 1 inch, 45. So the raw material is going to start here at that corner and come over 1 inch and then chop it at 45. So I'll put that at 1. And now you've got a dimension here. Okay. If I dimension this one here, okay, that's not 1 inch. It's going to be bigger. If I wanted to, I could create a reference of it so you can see. But that's not how you would do it. You just go over 1 inch and chop it at 45. Okay? The other thing you might have watched is, why did I dimension that and then dimension the rest? Here's what I knew. I wanted to control the width of this notch. So I know if I measure over here and I measure this notch, the greatest this notch is going to be is 203, and the least it's going to be is 1 97. Okay? What I see a lot of people do is they highlight the whole thing and they go right to auto constrain. And they reference this and they stack dimension it. Well, if you do that technique, I'm trying to move these dimensions out so you can see. My goal for this notch typically is to be a certain size because something probably fits in there. In fact, we're going to get more in depth in this when I go and talk about tolerancing. But for right now, I'll over constrain it so that we have a reference. Okay, it should be right here, change dimension, but I'm just going to move it up here because it's not really what I'm doing right now. I will try and get the reference on here. So, engineering tolerance is typically 30 thou. So if I was working with a 30 thou engineering tolerance, this dimension could be 3.53 and still be within engineering tolerance. What I should do is, I didn't like the way the part shifted. What you want to do is establish your datums so that it won't move on you. Okay, so if I change this to 353, the smallest this number could be is 147. But you'll notice that that makes that notch 2.06, which might be fine if they worked out that way and something were to fit inside of it. However, if I were to reverse that and change this to 1.53, being the highest limit it could be, and the lowest limit this one could be 3.47, 30 thou engineering tolerance removed. Now this notch is only 1.94 big, and if it were a 2-inch block in there, maybe I don't have enough room now to go and fit into that. So what I knew was I wanted to control the size of the notch. I'm just doing a quick undo. Whoops, I did a little too far. I'm going to do a quick trim and blow out these lines here in the middle. Lord. Okay, I have that shape. So knowing I want to control the size of the notch, I knew I wanted to chain it. So I highlighted it. When you go to auto constrain, it defaults to chain mode. So you just say okay, and it's just going to chain dimension everything that's there. Now that I have that there, I'll stack dimension the rest. And the computer's pretty good about figuring that out. Some of you might have been wondering, why not put the chamfer in here at 1 inch? I got it set to the proper length and angle. Whoops. That's all fine. When I go to auto constrain this, see what I'll do is it'll change dimension to this, and I don't want that, okay? Or even if I try and stack dimension this, and I reference these as my datums, okay, see what happened? I get all these problems with it getting fully constrained. It doesn't like it. So the rule I find for applying the auto constraints is corners, chamfers, notches last. Meaning, I don't put the corners in. I'm going to go ahead and highlight this before I do the chamfer. Stack dimension it. Tell it where I'm going to stack dimension from, using those lines as a reference. Highlight this. In fact, you can even see when I don't have those corner chamfers and notches I'm fighting with, those anchors are fine, okay? It's perfectly well, it's a fully constrained profile, and I can come back and highlight that and put the chamfers in after the fact, and it's going to be fine. It will go ahead and add those chamfers in, no problem. All right, so those are my tips and tricks to creating that particular profile. I try and do as many steps as I can within the sketch environment so that when I exit out, I'm going to build my pad. I had done another sketch in this exercise. I'll hide that for now. I'll select this profile, or select that sketch and go to pad after I put it in the part body. See, it's not even going to let me. Sometimes, once in a while, I get stuck and it doesn't let me move that around. I guarantee you're going to have problems if you leave it like that. So you really should start over, create this sketch where it belongs, then go ahead and go to pad. You notice that all the dimensions are on the back, and when I go to create the front view, the first plane it's going to see is here. So if I go 10 inches and hit tab or click anywhere, preview, when I go to make the drawing, the front face is going to be here. And all my it's going to be looking at it. For some reason my computer is really lagging here on my rotation. So I let go of the button several seconds ago and it's not doing anything. I'm going to go to view, flat, front. See, I'm really looking at that front view. All these dimensions or constraints are on the back. That doesn't even make sense. I want to reverse that, preview that, so all my constraints are on the front. When I make my drawing, all the constraints are on the front. When I'm setting my datums and all that, they're coming from here on the front face. I'll select OK. All right, actually, this part isn't quite that thick. I think it's only 1 inch thick, or 2 inches thick, maybe. So I could have come in here and put the chamfers, but I like to have as few steps in the part body as I can, just to keep it simple. And I got to add 2 more chamfers on the back. Simple enough. What I like to do is make the part transparent by using wireframe. Then I can use the chamfer command, and I'll chamfer the back edges. And see that when I have the wireframe on, I can go right through the part. And that chamfer on the back, I believe, is a 1/2 inch chamfer. So I'll just go 1/2 by 45. And now this part is complete. Okay, you were given an axis to locate the part on. You should know how to create the axis yourself. I just wanted to show you how I would go about building this part. Odds are there's probably an easier, faster way than what you did. Alright, that concludes our video on lesson 4, exercise number 1. If it were me, I would fast forward the videos. I probably should have said that in the beginning, just to watch through it and get through the concept and see if you can't duplicate what I'm doing. If you need to, you can always pause and rewind the video.